Hello, everyone. Dan here. In today's episode, I'm excited to share my favorite setup for working with Postgres in Python, Pydantic and Psycopg. In this episode, we'll explore how to write clean and efficient Python code for CRUD operations using Pydantic and Psycopg. CRUD stands for Create, Read, Update, Delete. We'll focus on techniques that promote code readability and maintainability while keeping performance in mind. All right, let's jump right in and take a look at the code in PyCharm. Don't forget, you can find the complete code for this episode on GitHub. There's a link down in the description below. If you're new to setting up Postgres in PyCharm, I've got you covered. Check out my previous episode for a walkthrough. The link is also in the description. Okay, let's start by defining our database schema. Make sure you've connected to your Postgres database in your script and added the schema you want to use to the search path. I called my schema demo for this example, but feel free to name yours, whatever works best for you. Here, we'll create two tables with this SQL script, a user table with ID and name columns, and a transaction table with ID, amount, payer ID, and payee ID. The payer and payee IDs are foreign keys referencing the user table. Now, to create these tables in your Postgres database, go ahead and execute the SQL by clicking on the Execute button in the top left corner of the script. You should now see the two tables, users and transactions, created within your schema. Okay, now let's take a look at the pedantic models we'll use for representing our database objects. For each table, we actually define two separate models, one for reading existing records and another for creating new ones. This approach of using separate models for reading and creating records offers some real advantages. Firstly, it allows for stricter data validation. By defining a specific model for creating new entries, we can ensure only the expected fields are provided. This prevents unexpected data from entering your database and keeps things clean. Secondly, separate models promote cleaner and more organized code. The reading model clearly reflects the data structure retrieved from the database, while the model for creating entries focuses solely on the required data. This separation of concerns makes the code easier to understand and maintain. The user model is straightforward. It just reflects the structure of our user table, with ID and name fields. The user input model focuses on the data users provide, which is just the name. The ID field isn't required for user input, because it will be assigned automatically within Python using Pydantic's computed field decorator. The transaction model includes the ID and amount fields. It also has payer and payee fields, both of which are of the user type, allowing us to connect transactions directly to users in our database. It's common practice to extend models like this one by leveraging the foreign key relationships, which can unlock powerful features for data retrieval and manipulation. Finally, the transaction input model keeps things simple. It focuses on the data needed to create new transactions: amount, payer ID, and payee ID. Just like with the user input model, the ID field is handled automatically using Pydantic's computed properties. All right, with our Pydantic models in place, let's move on to defining the database operations. Before we dive into the SQL statements, make sure your Python script has an active connection to your Postgres database. This allows PyCharm to recognize your schema, which makes writing the SQL much more convenient. PyCharm offers auto-completion and syntax highlighting for your schema elements, saving you time and reducing errors. Now, let's move on to the SQL statements. As you see here, we've defined both get and insert statements for both the user and transaction tables. In all these statements, we use special placeholders with keys inside. This is a neat trick. By providing data as key value pairs to Psycopg, it can automatically replace the placeholders with the corresponding values. This keeps our queries clean and helps prevent SQL injection vulnerabilities. Let's dive into the insert user statement first. This query inserts a new user record with both the ID and name fields, and it returns the newly generated ID. This is a good practice, as it allows you to easily retrieve the ID of the inserted user for further actions. Next up, the get user statement. This one's quite straightforward. It retrieves a specific user by their ID and returns all the user's information. The insert transaction statement follows the same pattern to the user insertion. It inserts a new transaction record with ID amount, payer, and payee information and returns the ID. Finally, let's examine the get transaction statement. This one's a bit more interesting. It leverages the power of joins to retrieve a specific transaction along with additional details. We join the user table on both payer ID and payee ID. This allows us to fetch the user information associated with each role in the transaction. Additionally, the statement utilizes the row to JSON function, a neat feature that transforms the payer and payee rows into JSON dictionaries. By using row to JSON, we can fetch the data in a format that can be directly handed to Pydantic models with a single database request, streamlining data processing. Pretty neat, right? Now, let's talk about the CRUD class. This is the workhorse that handles all the database interactions for us. CRUD stands for Create, Read, Update, and Delete, which are the fundamental operations we perform on data. The key here is that this class should focus solely on the core database operations themselves. It should act as a clean layer, keeping business logic separate. This separation helps maintain clean and manageable code. I will walk you through my preferred approach to setting up CRUD operations. The CRUD class takes just one argument, the database connection. This keeps things simple and focused. Let's dive into the first method, the generic insert resource. Notice the underscore at the beginning of the name. This is a Python convention to indicate that this method is intended for internal use within the class and shouldn't be called directly from outside. The insert method takes two arguments. The first is an insert SQL statement, as we saw earlier. The second argument is an instance of a Pydantic model. The method uses the with statement to open a new cursor, ensuring it's automatically closed later. This cursor then executes the insert statement with the serialized data from the model instance. Finally, the method returns the newly inserted ID, allowing you to keep track of the created entry. Next, up is the generic method for retrieving a resource. This method, for internal use only, accepts three things: a SQL statement to get the data, the type of data you expect as a model class, and optional filter criteria provided as key value pairs. This method also uses the with statement to ensure proper cursor management. Here's a cool feature of Psycopg. You can pass a class as a row factory to the cursor. This automatically converts fetched data into instances of that class, a very elegant and efficient way to work with your data. The cursor then executes the SQL statement with any key value pairs you provide. If it finds a matching record, the cursor will return a full-fledged model instance. Let's move on to the get and insert methods for both users and transactions. For creating users and transactions, you provide the user or transaction input object directly. These methods then call an internal insert function with the appropriate SQL statement, depending on whether it's a user or transaction. Similarly, for retrieving users and transactions, you provide an ID. The methods then call our internal get function, supplying the relevant SQL statement, the model class, and the ID as a keyworded argument. Now that we have everything set up, let's see how to use our CRUD functionality in practice. First, we'll use the con info helper function from Psycopg to create a connection string that holds all the information needed to connect to our Postgres instance. Now we open a new connection to our Postgres database using a with statement. This ensures the connection is properly managed, and any changes we make are committed to the database before closing the connection. Inside the with block, we'll pass the connection object to our CRUD class. Then, let's create some user objects with names Dan and Ann. We can insert these users using the insert user method, and then fetch them back using the get user method. We print the retrieved users to see the results. Now let's create a transaction where Dan is transferring a certain amount to Ann. We can insert this transaction using the insert transaction method, and then retrieve it again with get transaction. Finally, let's print the retrieved transaction. Because we defined join the users to our transaction in our get SQL statement underneath, the retrieved transaction will automatically have full user objects populated in the payer and payee fields. Isn't that neat? And all of this is achieved with just a few lines of clean and easy to read code. All right, everyone, that's it for today. We've explored how to combine Pydantic with Psycopg to write clean, understandable, and blazing fast code for interacting with Postgres in Python. I hope you enjoyed this episode. In the upcoming ones, we'll dive deeper and use this powerful setup to build real-world applications. If you found this helpful, be sure to leave a thumbs up, subscribe to the channel, and hit the notification bell so you don't miss the next episode.